to EC TechNest. Today, in the day 27 of 100 Days Digital Design and Verilog series, today we are going to talk about a simple and basic concept that is half adder and full adder. A half adder is the simplest form of digital addition. It takes two binary inputs and produces two outputs. Sum and carry are the outputs. However, it cannot handle a carry in from previous stage. That means if I have two adders in continuous thing, I cannot put the carry in as an input to the other adder. So the carry is just remaining over here and it is not getting added up in the next thing. So only for two inputs, half adder can be used. If you have like more inputs, you need a full adder. This is the block diagram of a full adder, and this is a logic diagram. One thing you need to understand that how do we get this? You have 0, 0, 0, 1, 1, 0, and 1, 1. And your sum, when 0 and 0 are added, you get 0. When 0 and 1 are added, you get 1. When 1 and 0 are added, you get 1. When 1 1 is added, you get 0 because it goes on to the carry. See, you can see that carry is a dot b, but whereas sum is a bar b plus a b bar. So I get an a XOR b. This is how you get the logic diagram of a half adder. Now this is the EDA Playground simulation of the half adder. I have my design here, module half adder, input a comma b, output is sum and carry. Assign sum is a XOR b as per this, and carry is a and b. Timescale 1 nanoseconds with a precision of 1 picoseconds. Module test bench half adder. I have registered the inputs and the outputs are given as a wire, sum and carry. I have instantiated the unit under test for module half adder. Now I'll begin the thing. This is used for dumping the half adder code into the simulation. Because I'm using an Aldec Rivera Pro, I have to use this. Now comes to the main part of the code. Here I have used a display statement, that is time AB sum and carry. That means this part, it will display this. Then for this I have used a monitor statement because based on the inputs applied, this has to keep changing. That's what I have done. Dollar monitor percentage 0t percentage b b b, because I want everything in binary. Only time will remain in t. I have dollar time a b sum and carry. When it is 0 and 0, my sum and carry will also get updated. That is how this code is going to work. Now let us see the simulation. So when you see the code, my a and b was 0 0. So what has to be my sum and carry? Both will be 0 0. Now I have 0 and 1. So my carry is 0, but my sum is 1. Now I have 1 and 0. So my carry, what is this? Yeah, carry is 0 and sum is 1. Last will be 0 0. So carry will get updated. See, carry is getting updated here. You can see the rise. It is going to 1. And my sum will become 0. If I am not wrong, this is what the truth table says, right? Next we have the full adder, the block diagram of a full adder. One thing that you have to see is it is just a continuation of the half adder. Only thing that gets added here is the last input cn. Whatever was the carry in from the first stage is getting added to the next stage. Let us see how this works. You have three inputs: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So here we have to see that when we have 0 0 0, sum is also 0, carry is also 0. So when we add these three numbers, my sum is 1, carry remains 0. Same goes here also. Here we have 1 1, so it becomes 0 1, and here it's the same again, 1 0 0 1 0. Since we have two ones, it goes as a carry. Here also it goes as a carry. 1 1 1, we get 1 1. When we make a binary expression out of this, we get see wherever we have 1, see it's a bar b bar c in, then I have a bar b c in bar. So when I add all this, I get sum as a XOR b XOR c in. Same way, when I do this, I get c out to be a dot b plus c in dot a XOR b. As I said, the full adder is nothing but an extra carry input being given. Now I have the code for module full adder. Input a comma b comma c in. Output is sum and c out. Assign c out comma sum is equal to a plus b plus c in. Nothing but I'm adding all the three inputs. Whatever is my sum will go to this sum, and whatever is my c out will go here. There is also another method to write this, that using the XOR gates, or the logical gates that I'm using here. Sum is a XOR b XOR c in. C out will be A and B, or C in A and B, A XOR B. So if I'm not wrong, this is what I have got here, right? So I have put it in the code. Here the main thing we'll see is the same thing. I have given time scale with a precision of 1 picoseconds. Register A comma B comma C in. Wire is sum and C out. I have instantiated the full adder, and this is my dump file for Aldec Rivera Pro. Since I'm using Aldec Rivera Pro as a simulator, I have to write this, or else I will not get the test bench outputs. For integer I is equal to 0, I is less than 8, I is equal to I plus 1. So what I am doing is, based on this three inputs, I am giving random variables. So all of my test inputs are checked. Now I am ending the simulation, and I have given dollar finish. I am ending the module. This is very important. What we did in half adder was, I gave the test simulation. Instead of writing every time with 0 1 1 0, what I'm telling is, I am initializing a comma b comma c into a random variable I, or an integer variable I. So I tell that whenever I is equal to 0 and I is less than 8, I have to increment. So it will go on incrementing. It will begin with 0 0 0, it will go 1 1 1, so that it will go on incrementing one by one. So your test case will find out all the outputs. Now we'll see the output. See, if a b c are 0 0, so my sum and carry out will be 0 0 0 1, I'll get 0 and 1. 0 1 0, I get c out, carry out to be 0, and my sum to be 1. Similar way I have tested for all the other cases. You can cross verify this. Now we'll go to the EDA Playground. I'll give the link to this EDA Playground in the description. So what happened is, in the previous videos, a lot of my juniors were asking that they did not know how to simulate this. So it's a very easy way. Once you have written the code, just save it once. And here, if you have test bench plus design, set it to system verilog plus verilog. Then you can come here to the tools. You need to set Aldec Rivera Pro 2025.04, whatever is the latest version. And remember, your time scale here you have given as 1 nanoseconds and 1 picoseconds. Just change it. If somebody doesn't know what is time scale, I have done a separate video on this time scale. What are the different types? Why is it we have tried 1 nanosecond by 1 ps? What is the need of it? What is 1 ps? What is this precision? Everything I have explained in that video. You can go and check that out video. Now this is my half adder. Once you have done all this, just need to run the code. The code has run successfully, and I have got my output. Once here, you need to check the log file, and if you have got the output here, you can cross verify with your waveform. Similarly, for a full adder, what I'm going to do, I'm again going to save it, and the same steps, system verilog and verilog. Here it's again 1 picoseconds. Open EP-Wave after run. EP-Wave is your waveform viewer. And I go to the log file. Here I'm not going to get any output because I haven't used, see, the thing is, I haven't used a display statement here. Here I have a display statement, but in the same case, for a full adder, I haven't done that, so you do not get it here. Instead, I get a waveform directly. So this is how you can use your EDA Playground to do small simulations. Yeah, link to both the playgrounds will be in the description. If you have any doubts, feel free to put it in the comment section. Thank you.